we doing again, everyone? Today we're going to look at solving basic one-step inequalities by using addition or subtraction, and then graphing our solutions on a number line, as we've done in the prior video. So what we've done before, based on our classes, we've had equations where we have that equal sign between our left and right side of our equation. We have variable on one side, and then our equal sign. If you remember, we drew a vertical line to signify or represent that equal sign. So that's where we're going with this one. But the only difference today is that no longer is it an equal sign. Now we have an inequality sign. So there are four possible. We have the less than, we have greater than, then we have less than or equal to, or greater than or equal to. Those are the four signs that we're going to be working with today. And they work very similar, especially with addition and subtraction. They work very similar with just solving an equation. So here's where we have to figure out again. Again, we have this vertical line. That could represent, again, our inequality sign, which in this case is less than. So my question to you is, where is our variable? Is it left or right side? Well, if I look up here, x is on my left-hand side. So what do I have to do to get x alone, to get it by itself? In this case, we need to figure out how to get a positive 7 over here. Well, the only way to get x alone, as we know, is to subtract 7. And if I subtract it from that positive 7, I have to subtract it from the positive 2 as well, subtracting it from both sides. And the reason I know I'm getting x alone is because I'm making 0. 7 minus 7 is 0. X is now alone. My inequality sign just drops on down. So this just comes straight on down, and now this is x is less than 2 minus 7 is negative 5. And that's our solution. Now, I did jump a little early. This is our mathematical solution, but it's not actually showing every single value. And the way we show that is we create our number lines and graph this solution on our number line. Now here I'm creating my own graph, so I only have to determine where 0 is, and 0 is directly in the middle of our number line. The reason I put that there is because now I need to know where is negative 5. Well, negative 5 is to the left of 0, so I could physically count over 5, plot negative 5, and now it's back to those two different types of points. I look here, if you remember from last time, x is less than. The key words that I'm looking for are equal to. Well, if x is not equal to, then I'm going to be using my open point. So here's my open point. I place it at negative 5, and then I have to shade. If you remember, shading the direction, where are all the values that are less than? Less than always to the left. So I just come up and I shade the rest of my number line all the way to the left. And as the graph, we have the mathematical answer up here, and we have our graphical answer down below. Another example up here. Now we're going to look at this n minus 24 greater than or equal to negative 15. Again, identify where your variable is. In this case, I see it's on the left-hand side of my inequality, so I need to get n by itself. Well, to get n by itself, a negative 24, I must add 24 to both sides, so add it to the negative 24 and add it to the negative 15. And again, just like solving an equation, negative 24 plus 24 is 0, so then my n can drop down. My inequality sign can also drop down because I'm only adding this 24 over here, so n is greater than or equal to. And now I just make it an integer problem, which negative 15 plus 24 is a positive 9. So there's my mathematical solution. Now I have to graph it. I'm going to come up here, create my number line, place 0 in the middle. And again, just to remind you that if we ever have a numbered number line, obviously we could just go to that positive 9 and fill in with whatever our point is. In this case, I'm creating it. So if n is greater than 9, or excuse me, greater than or equal to 9, I could simply just plot a space for 9 to the right of it, because this distance could be anything. It could be going up by 2s, by 1/2, anything I want. And now at this 9, I'm going to plot the type of point. Well, here are my key words. N is greater than or equal to. That or equal to tells me I not only have a point, I have a closed point at 9. And then n is greater than, well, all the greater than values are graphed to the right. So I'm going to come up here and shade my number line to the right. So now I have an accurate graph, and I have an accurate picture. Or excuse me, an accurate solution. One more example, adding and subtracting. I think you understand the basic concept of what we're doing here. This time, where's our variable in our inequality? Well, this time it's on the right. So that tells me I'm going to have to do something in the very end. I'll get to that in a moment. But just for balancing, how do I get this m alone by itself? Well, I have to make this 4 0, so make a positive 4 0 by subtracting 4. If I subtract 4 from the positive 4, I have to subtract it from the 6 as well. And again, that's this. We're doing it two separate sides of that inequality. 4 minus 4 we know is 0, so the m may drop down. The inequality sign will drop down as well. And then 6 minus 4 is 2. Now from here, as I said, I'm going to have to do something different because our rule via the last video was write your variable first. And in this case, m is not coming first. So what I need to do is rewrite this as m, and if I want to, I can just put the 2 to the right-hand side of the m, and then figure out which direction is this inequality sign facing. Actually, it's eating that little 2 right there, so in this case, 2 is greater than or equal to m, which is the same as saying m is less than or equal to 2. So now I have my solution. And in order to graph, I can create my number line again. 0 is right in the middle, and now I'm going to come up and graph my points. So in this case, I'm plotting 2. I can actually write the 2 on there. I can place a closed point on 2 because m is less than or equal to, those are my key words, and then the less than values, we're shading it all the way to the left. So in this case, I'm shading all the way down this number line. So there's an accurate graph, and then there's your accurate solution. So if you notice, in every single example, I have my mathematical answer, and it actually coincides with what my graph is showing here. So, actually, in fact, that is your keyword today. So before you go through the video, before you go through the form, your code word for the form today is coincide. That's your word. And what that simply means is it goes together, one thing goes together with the other. So here, my solution goes together, coincides with my graph in every single case. Okay, so do the best you can on the form, and look forward to working with you again.